Hi guys, this is Colleen. The unit that I had is Unit 2, which is talking about scatter plots, and I had Chapter 10, which is re-expressing data. Okay, so the first thing we have to ask ourselves is why would we want to re-express data, and these are the two reasons. Re-expressing data can stabilize the variance of a graph. It can also help to fit a curve. There are also 4 goals in re-expressing data, and these are the following goals. Goal 1 is to make the distribution of a variable more symmetric. Goal 2 is to make the spread of several groups alike, even if their centers differ. Goal 3 is to make a scatter plot more linear. And goal 4 is to make the scatter more spread so that all of the dots aren't in one place. Usually when we are re-expressing data, we want to use the y values first because it's an easy starting point. So one of the most important vocabulary terms for part 2 of the chapter that we need to know is the ladder of powers. The ladder of powers is essentially a different way to re-express data. Some of the simplest examples of the ladder of powers are square roots, logs, and reciprocals. So this is a picture of the ladder of the powers taken from the book. These are some of the different examples that we can use to re-express data. So the first one it describes is we can square the data. We can use the raw data, we can use the square root of the data, we can use a log, we can use a reciprocal square root, or we can use the reciprocal of the data. Usually what they want you to do in starting to re-express data is use logs because it's a good easy starting point, and then if that does not make a clear linear model, then you can go and you can try square roots or you can try reciprocals. So now I'm going to talk about part 3, which is just some things to remember and problems that could go wrong. So as most of the things in AP Stats describes, is we always have to be sure to watch out for negatives and outliers that could affect the data. Some other things that we have to remember is that our scatter plot has to be linear. That's the whole goal of the re-expression. So this is an example of a linear scatter plot. Another thing to remember is that you cannot have multiple modes when re-expressing your data. So that's what this looks like right here. And then it cannot go up and down as you see the graph going up and down. But one of the last things to remember is that your re-expression will not always be perfect, but it will be more useful to use in a real life situation. The reason why these problems are so significant to us is because many of them are used in real life scenarios. So now I'm going to show you guys a couple examples from the book. The first thing that I'm going to talk about is why re-expression is significant, or try to give you guys an example of how it can be seen in real world situations. So the first thing I'm going to look at right here is an example that talks about the difference between weight and fuel consumption for a car. It's talking about gallons and how far a car can go. So it talks about how everywhere else in the world they use kilometers to measure fuel efficiency, but it talks about how in the United States we use gallons. So at the bottom here it talks about how multiplying by 100 to get gallons per 100 miles makes the numbers easier to think about, whereas in the United States we don't really use kilometers to measure how far your car can run. So this is talking about how to linearize it, they divided gallons by 100 miles to make it easier for us to understand. This is just another example of some of the goals of re-expression, which is to make the histogram more normal. So it talks about right here, they're talking about the difference or the association between assets and number of companies. So right here, as you can see, it doesn't look normal at all. It is skewed more towards the right here. And then when they use the log of assets, it looks almost perfectly normal. So I am going to show you guys a quick example out of the book here where we're using the attack of logarithms in order to re-express some data points. So right here the example talks about the relationship between f divided by stop of a camera's lens and its shutter speed. So we're going to use logarithms to re-express the situation. So I'm going to show you guys how to put this into your calculator and then how to re-express it in your calculator. So what you guys are going to do is, just like we always do, we're going to go to Stat, Edit. We're just looking at L1 and L2 for right now. And we are going to put these two sets of data into L1 and L2, just like I have here. The next step is to create a scatter plot. So I'm going to go to second, y equals, and then I'm going to create my scatter plot. As you can see, there's a little bit of curve in the data. It doesn't look perfectly linear. So we are going to go ahead and re-express it. And the way that we do that is I'm going to go to Stat, Edit, And then I already did this in my calculator, but usually it's a little bit easier to go ahead and re-express the y values instead of the x. So I'm going to go up to L3 and I'm going to take the log of the y values. So I'm going to type in log of L2 since the y values are in L2. And then if I press enter, sorry, enter, as I already did, it recalculated all these values for me, and it's going to try to make those more linear. So the way that we're going to do that, we're going to go to second, y equals, to show another scatter plot. This time for our y list, we're going to be looking at L3 instead of L2. And then we are going to create another scatter plot, and it should appear more linear. If it does not appear more linear, you can go ahead and use any of the other re-expressions shown in the ladder of powers in order to re-express your data. So to end the video right now, I'm just going to show you guys the ladder of powers one more time. This is going to be the most useful thing in re-expressing data. And then just as a review, the most important things to remember from this chapter are your 4 goals, so why you would want to re-express data, some of the problems that can occur, just a reminder, those examples would be multiple nodes or graphs that go up and down or graphs that turn around or outliers or stuff like that. And just remember, if you try one method of re-expression and it doesn't work, you have all these other methods of re-expression from the ladder of powers that you can use. If you guys have any questions, feel free to ask us. There are also lots of practice problems and multiple choice problems on there for you.